This computer only works colder than outer space.
This chip costs more than most houses.
One vibration can destroy the calculation.
So why are we building it anyway?
This chip does not run hot. It doesn't sit on a desk.
It only works when it's colder than outer space. At minus 273 degrees Celsius.
Normal physics breaks down.
Electrons stop behaving like particles.
Information becomes uncertain.
This is the most expensive computer chip ever made. And almost no one knows how it's built.
This is how quantum computer chips are made. Classical computers live in certainty.
Every bit is either 0 or 1. Quantum computers do not. A qubit exists in both until you look. Observation destroys the state. Even standing too close can matter. Heat, light, vibration, noise. Errors appear without warning.
Stability is temporary. Failure here is silent. The safest action is often no action at all.
Even now, no one fully understands what's happening inside. So how do you build something this fragile?
Everything begins with materials that behave too well.
Impurities here are measured in parts per billion. Some quantum chips are built on crystal instead of silicon.
These metals only reveal their purpose when frozen.
Once inside, nothing organic is allowed to interfere. Even gravity becomes a concern.
One dust particle can erase weeks of work.
Now, matter is added atom by atom. Each layer is thinner than imagination. At low enough temperatures, resistance disappears. Success is expected. Failure is not forgiven. Perfection is not optional.
Most wafers never make it past this point.
In this quantum environment, every movement is calculated, every breath filtered. Precision is paramount to avoid contamination.
The air itself is engineered.
Next, the impossible patterns are drawn.
This room looks clean, but it's hostile to mistakes.
Once locked, nothing can be adjusted. The beam is smaller than a virus.
Heat locks the chemistry in place.
This is where logic is written into matter.
Hours pass. The room never reacts.
Each line is smaller than biology.
These patterns make biology look large. Now, material is removed with controlled violence.
Too much, and the chip is dead.
Now, layers are rebuilt, one atom at a time.
The process refuses to rush.
This is where most designs fail.
This one survives.
Now, these patterns must behave like atoms.
These shapes are not wires. They are artificial atoms.
This gap is thinner than imagination.
Electrons cross where physics says they should not.
Each qubit must sing at exactly the right frequency.
Information is delivered as waves.
Until measured, it exists in more than one state.
Change one, and the other responds instantly.
Too close, and they destroy each other.
Isolation is engineered into the design. Each one is fragile. Together, they are powerful.
Errors never disappear. They are managed.
Shielding buys time, nothing more.
Coherence lasts only milliseconds.
Human presence is always a risk. Now comes the cold.
This machine does not cool things.
It removes heat, layer by layer.
Every wire is a potential source of noise.
Even footsteps can destroy computation.
Radio waves are treated like threats.
From 300 Kelvin to almost nothing.
Cooling is achieved through separation, not freezing.
Installation is performed like a ritual. After this, nothing can be adjusted.
Cooling begins.
From this point on, the system is alone.
Motion nearly stops.
This is as cold as engineering can make reality.
The first signal enters the cold.
Coherence begins to leak away.
The universe is loud at this scale.
Every correction risks making it worse.
Stability never lasts long.
Observation ends the computation.
The answer is never a single number.
Errors can be corrected, but never eliminated.
One reliable qubit can require hundreds. Even here, heat finds a way back.
Sometimes,
The safest result is stopping.
And this is why quantum computers are still experiments.
One quantum computer fills a room.
The chip costs millions before it ever computes.
Every qubit needs its own control line. Scaling breaks everything.
No one agrees on the winning design.
Yet investment keeps growing.
No one can agree on when it will arrive.
Chemistry. Materials. Security.
Progress here is measured in patience.
This is not the future yet, but it is the beginning.